great speaker. He's also a great boss. He's a tough boss, very tough boss, very demanding, but he's a great boss. Good vision. It's always nice to have a boss that has a vision. I can tell you when you're on the path and when you're not. A lot of things. I do have charts, partially because I wanted to show you a little bit about where Orion fits in the big plan today. I'll touch on some of the things that Mike mentioned too about some, where the plans are, but it's changed a lot since when we started Orion. But also the title talks about EFT1, which talks about we're beyond the visionary pictures. We're actually flying a flight in December this year, less than 4 months. We're going to lift off from the Cape and come in at near lunar entry velocities and then land off the coast of California. And I'll talk a little bit about where that flight fits. And I'm not entirely sure how to do this, but I'm going to guess. Are my charts on here?
Are your charts on there?
Yeah.
Well, did you give them to us?
That's good. I did, but here, let me get the stick. Sorry about that. My guys did, but I think probably it was. So Orion, what I'm going to do is show you a couple of pictures. Where? So let me start. I'll start describing the first few charts, assuming I can find the USB port here. How Orion fits in the overall NASA strategy. Orion is a piece of. Let's see. How do I do this? Here we go. Orion is a piece of a strategy. Along with SLS, and I know Todd May was here yesterday. Todd and I are good friends. We worked together for years, starting the space station. Let me see, I think I'll transfer the file first. And I'll talk about how SLS and Orion fit into exploration. But we're also about a part of the overall NASA plan, which includes looking at these commercial providers going to space station. And let's talk a little bit about how they fit together, because they are not in competition, but rather part of the same strategy. There we go. Oh, it actually worked. Okay. I always feared trying to make these work on a Mac because it wasn't built on a Mac. Great, okay. So there's this huge astronaut dude looking at Mars. So that's my first chart. Next page. Let's see, so go page down. There we go, great. Okay, so this gives you kind of a scope. Space station obviously is a huge part of NASA's mission in the near term. We did it. I was part of that, for working on space station for 12 years, working a lot with the Russians. Now it's up there, it's flying. Now we're doing the research, setting records for research time these days. Actually turned a lot over to commercial providers to look at ways of utilizing space station. But the key is let's get the cargo and the crew up there as cheaply as possible. Along with actually having a U.S. capability. So that's what these commercial providers are doing, and of course Orbital and SpaceX did a terrific job of getting the cargo up there. So now they're transitioning to the much harder job of getting people to space station. And they're just about to award those contracts for the next phase. Then Orion and SLS are really the missions, obviously, the capabilities we need to go beyond low Earth orbit. Low Earth orbit is difficult. But beyond low Earth orbit is obviously the next phase. It's a lot harder than low Earth orbit because mass is so precious. For example, every pound of mass that you start at LEO and you want to accelerate it even just to the moon and get it home, you multiply by 9 all the stuff, propulsion systems, propellant, everything else it takes to do that. So every pound is precious for beyond Earth orbit. It's been a big challenge. For us, it was for Apollo. And also the reliability and safety systems have to be much more rigorous, because when you're in Earth orbit, you can get to the ground pretty quick, 45 minutes or so, you can be on the surface of the Earth. When you're around the moon, it can be 7 days. You can be a long way away. So you've got to have systems to protect the crew for all these contingencies. So much different mission. And obviously SLS gives us that forced velocity and everything else to get us out of these regions. So it's a much different mission, even though they look similar. Orion's kind of pointed and it's white. It's a much different capability to go beyond Earth orbit. So that's an important part. We're working together to achieve both of these missions. Todd talked, I'm sure, yesterday about how SLS helps us get there. We are tied to SLS. Both of us are needed to do this job. SLS gives us, obviously, the delta V to get to these regions. We have Lagrange points, near-Earth asteroids that we can visit, and then, of course, Mars. And, of course, Todd's plan is we start with a 70-ton, which allows us to get started, allows us to do these tests around the moon to flesh out these systems. And then I'll talk a little bit about the asteroid mission. But then we can also, it can grow easily with the upper stage change to 130 tons. So that's really important, flexibility and adapting. Orion's capability, again, this is an example of a mission. This would be a habitation module. You could use this then to go to an asteroid rather than bring one back and go look at it. In this case, because of the duration, which could be 6 months or longer, you would need a HAB module both for the, mainly for the food and the water and those kind of things, and for exercise equipment. That duration would require those kind of things. What Orion provides, obviously, is it gets you up into the atmosphere safely, because we can board off the launch vehicle at any phase of flight, so it's very safe for the crew, and we get the crew home back to the surface of the Earth. It also provides sufficient volume to launch a range of crew sizes, so we can launch 6 people for shorter durations. We can launch 4, which is our nominal. And the volume allows you with 4 or even, let's say, 2 people to extend their duration and also do other missions. So this asteroid mission, and we'll talk a little bit about it, we can do that whole mission, the asteroid retrieval mission, without any other elements, because Orion has the volume to store the food, and also we can use the cabin as a PDA airlock. So I think this is a really good example of, as Mike mentioned, you know, there are political realities. We get these very tactical decisions. I want you to go do this, I want you to go do this. Let's add the Russians to space station. That was really easy. Let's have Constellation. Let's don't have Constellation. Those are political realities. They happen. I've learned to let go of the stress of that and recognize that the key really is to provide a system that's flexible, that can do a lot of things. You know, we can go to the moon. We can go do this asteroid thing. We can go to a far asteroid. We can be part of a Mars mission. All these things are possible with Orion. It may not be perfectly optimized for any particular one, but it can do all of those as part of that mission. I think that's the key for enabling moving forward to have any capability. And so we can do a lot of missions when, as the country decides that they have a particular target they want to go after. So Orion is a survivor. And the team's done a great job to get us to this point, including having a launch this fall. So there's a lot of little things you can do. You know, there's simple things we did in Aviation Week. Talked a little bit about there could be lunar sample return. You know, this very small modifications to Orion allowed this to happen. We can capture this with a docking system in the front, an airlock in the front, simple things like that allow you to do a lot of different things with the system we have. Again, another habitation module further, and eventually. You may have seen Lockheed had a concept where you could have 2 Orions together. This would negate the need to start a new development on a HAB module. The other Orion could be lighter. You would need heat shield, for example. You could also take other systems off because the crew is in the other one. Basically use that volume. So for ops cost-wise, or the production cost, it would be a fairly expensive HAB module, but it'd be a lot cheaper than spending the development money to build a new HAB system. So there's ways you can combine your systems to get some of the missions you want. And again, it can be would be part of a Mars system. Already talked about SLS, so we'll go to the next chart. This is Orion breaking out in pieces. This is Orion on top of the stack of the rocket. So this is where the crew resides. Again, we can hold 6 people, and our nominal is 4 people. We have a launch abort system on the top. This is, again, gets you off in the most energetic phase of the launch vehicle flight. It's a 500,000-pound solid rocket motor. We also have a solid rocket motor attitude control motor here that's based off of Brilliant Pebbles. The program allows us to control attitude. I think last year when I was in Boulder, I showed you the video of Paddle 1, the test we did where we actually fired these motors and did a control paddle work in 2010. Behind the Orion capsule is the service module. This is where the solar arrays are, the radiators are, the propulsion system, and all the consumables, the big consumables, water, air. So that's the layout. Mike talked about international partners. I think international partners are key. I think it's key for us to lead like we did at the space station, but I also think it's essential that we go with our partners. One, they help us financially, and two, I think it gives us stability in some of these political changes we've seen. We certainly saw that in the space station. Also, but you got to pick your targets. You got to pick the right things where it makes sense to get partnerships with partners. So in this example, ESA is providing, not for this flight in December, but for the flight, the next flight on first flight on SLS, what we call an ESA service module. It's basically part of the service module, the back end that has the solar arrays, for example, and the radiators. This is a great choice for ESA because some of these systems are very similar to ATV that's already flying to the space station. So you see, you look at solar arrays, they look exactly the same. But obviously there are differences here. The radiators are different. We're actually going to give them shuttle-owns engines. They exist. They provide the thrust we need. We have 11 of these from back from the shuttle program, so it allows us to reduce costs there too. ESA is fine. They're doing a terrific job. They just passed their PDR, but they're finding that beyond Earth orbit design is harder than LEO. The things they thought they could get by on Heritage because it flew to space station, they're finding it's much more difficult. Mass is a big part of that, and reliability. But we're working with them. They're doing a terrific job. And as I said, we just passed their PDR. This gives you a sense for the manifest. EFT-1, we're flying this flight in December is on a Delta IV Heavy because it's ready, and it gives me enough velocity to do about 85% of a lunar entry, so it's perfect for this task. Then we fly on SLS, as Todd mentioned. It's the next flight that'll be unmanned as we bring out all the systems. I have one more abort test. This will be a what we call a ascent abort. It's basically in the transonic region is the most difficult to control when you come off the rocket, being able to make sure you can hold attitude, so we'll be really testing that attitude control more. That one can move around. We're looking at doing that one actually much earlier because it's a fairly inexpensive test. And we're using a Peacekeeper stage, solid stage, to give us the thrust and get so we're going to keep the cost down. And then the first manned flight then will begin in 2021. This is a video of the flight in December. Again, it's a Delta IV Heavy, so this is not much different than you would see from the Causeway. A lot of the things we're going to be testing are the safety critical things that are difficult to model, including fairing separation. So the service module has some large fairings that allow us to reduce mass for the service module when we push it to the moon and beyond. But these fairings actually carry the load on the way up, and so they can take some of that mass we throw it up. We get rid of them, we take off the last system. Then the upper stage pushes us to this 3,600 miles. Space station is at 200 miles, gives you a sense for how high up we are. Again, that gets us very close to lunar entry velocities. Then we separate, and at this point, it's all on the Orion computers. All entry navigation guidance is done by Orion here. We're using our RCS thrusters, 160-pound thrusters. Obviously, the big test of this is the heat shield, which is the biggest heat shield that has ever been built for people and designed specifically for the Orion missions. Then you have all these pyrotechnic events. The forward bay cover comes off, parachutes, then you have drogues come out, then the mains come out, and we land. We'll be landing off the coast of California. In this flight, that's where we will always be landing as part of Orion. And then I'll show you another picture in a bit here about how we're synergizing with the Navy. Let's see. Okay. Here's Bob's favorite mission. This is the asteroid regret mission. I like the way Mike talked about it. Mike also is not a big fan of this mission, but this is what is important about this mission is it is the first mission that the president has supported as far as exploration. So we're working hard to see what is possible on this mission, and we're working hard with the guys at headquarters about the cost of the other systems like the SEP that is new. As far as Orion goes, as far as Orion and SLS go, we can do this mission, right? We have the capability. SLS gets us there. Orion has already tested rendezvous and docking system on a DTO to the space station on the shuttle. And obviously our whole design is set up to have docking in the front, so this is not a mod for us to do this mission. The crew cabin is made from the beginning for safety. We can handle a depress of the cabin, and the crew can could sit in their seats for 144 hours, right? This gives you a sense for how the system is built to protect the crew. So given that, the cabin's available or is designed to be depressed, we can use it as an airlock. So again, it's a slight mod. We're going to bring a tank that we can use to help repress, but we can do it. Orion and SLS can do this mission. The other key parts are the capture and this SEP system, which Ness is looking at. One of the things we're doing is when we in our trade studies, landing on water was the lightest option, and again, mass is a big deal when you go beyond low orbit. It's also the safest to get the crew to the surface of the Earth, because there's a lot of downloads you can do in the water, which is much more difficult on land, because you don't want to land in Los Angeles. The difficult part then, when you're on the water, is how to get the crew out. How do you get the crew out once they're in the water? You remember in Apollo, we did a couple of things. They got the crew out. The divers got them out and put them in the boats or got them in a helicopter, and then at Skylab, we actually lifted the whole thing up onto an aircraft carrier while the crew was still inside. So we're actually looking at improving that. Now with our guidance, we don't need the whole Navy. We're working with them on using one ship. It's called an LPD. That's the Anchorage, USS Anchorage right there. This is an extremely capable ship. It's a well-decked ship, which means there's a deck inside that they flood. And what they use now, they actually launch Marines with hovercraft and so forth. We're going to flood it, and then we're going to pull the Orion in and then unflood it. It'll be sitting down, the crew gets out in the dry deck. It's a great idea. When we synergize with the Navy, they love it because it gets their guys trained for operations. All I do is pay for the gas for the couple days that we're using them. They're really pumped about doing this. We just did our second test last week, finding out a little bit about how the capsule behaves in a well deck, and how to make sure that it's a safe operation for the crew. Another example of trying to synergize, save money, and get the best way to help the crew. They also have helicopters, so we can do a lot of filming of parachute drops. This is a picture, a video, like you're sitting on top of the forward bay of the Orion, which would be a bad place to be, by the way, right here. But we're coming out of the C-17, and then you just saw one of the mains be deployed. Pilots come out and deploy the mains. You see the mains, how they're reefed. They start out with a very small opening to reduce the jerk loads, and then we actually have a pyrotechnic device that opens the chutes further and further, about three different stages. So we test several different configurations. This is a Yuma. We test a lot of failures. We go to 2 chutes. We test drogue out. We test reefing failures, just to see how the chutes interact, because it's very dynamic and very hard to model. This is a picture of the service module. So now we're into the hardware that's going to fly in December. And this is where you can have all these really nice plans about what the thing's going to weigh, what it's going to cost, how long it's going to take to do. But until you actually build one, right? These are all just theories. So we now have built a flight crew module, and I'll show you the details of that, and a flight structure for the service module. And we're about to throw it into space. So this is a service module. It gives you a sense for the size. You see the guys down in the lower left. This cone is called the adapter, and on EM1, you would see the OMS engine would be in here, inside here. You'll notice this internal diameter is thinner than the 5 meters of the crew module, because we don't need any more volume than that. That's all we need to do the propulsion system and the consumables. But to reduce the mass of this interior side, I mentioned before, we have these fairings. This is a picture of one of the fairings, and if you go to the next page, then there they are installed. So these are actually loaded fairings on ascent. They're actually helping carry the load going up. So when we throw them away, then the internal side can be, the interior can be much lighter. And since that's the mass, we're pushing all the way to the moon's big deal. So it gives you a sense for that. But they're a pyrotechnic device that separate here and on these edges. Test for that, there we go. Here's the crew module itself. Heat shields down here. These are the prop tanks, the helium tanks. These are the thrusters here and here. And you can start seeing the windows here. This is the hatch, the main hatch. And up top are the parachutes. So, there's 60,000 parts, 10,000 drawings, nearly 100 suppliers. That is the big challenge of actually making something, is getting all those teams, all those parts, and it's always the last connector, right? The last insert that you're waiting on. That's the challenge of a team like this, to get this thing done. That's a picture of the heat shield from the bottom with the thermal tape on it. These are actually the CMSM separation bolts. They attach to the, down here to the SM, and those are actually pyrotechnic devices we fire just to hold separate. Picture from the top looking down at the integration cell. You look at, this is the ONC now, the Armstrong ONC Center. And these are the thermal chamber, or vacuum chambers rather, that we use to install. So it gives you a sense for where it's sitting. And there's the launch abort system again. On EFT1, all we're going to use is the jettison motor, but all the aerodynamics, the shape is the same. It's the real structure, the real flight structure. So we get all the aerodynamic data and we'll jettison this equipment. Yeah, I had a video, but I showed that, given that I showed that last year, and it really kind of shows SLS and Orion launching, but since I know we might be a little behind.
No, you can go.
Okay. Showed this last year too. There we go. So it gives you a sense for when we put them together, we're launching people, what they're like. And there would be sound, so I'll describe it to you. So basically, we at Kennedy, they're already building the launch tower. You'll see it. You'll see pictures of it there already. They've already upgraded the crawler, so the crawler system will be ready to handle these loads. Nominal mission will be 4-person crew, so it gives you a sense. This is very, very much how it's going to look when we get there. A lot of the same systems we use in shuttle we use to get the crew out to the pad. Oh, that's some guy you may have seen. He looked a lot better last time I saw him. There's the VAB. We will be stacking the SLS and the Orion in the VAB as well. One thing different about Orion than previous manned space programs is our factory is actually in Florida. In the past, we've built them sometimes in California, but actually all the assembly is done in Florida. There's a picture of the SLS on the Orion 39B, pad 39B. Mission operations will be a big part of this SLS and Orion system as well. MOD is actually a part of this flight in December, even though the vehicle itself does not need commands sent to it to do its job. We have some contingency commands in case we want to reboot the system or get any other issues. So we'll be flight following this flight in December as well. The music is much more dramatic. I can hum it. I can try to hum it. So the ascent is similar as you might expect. The boosters come off. Todd might have talked about that. These are shuttle-derived boosters, and then there's a lot of applause. No Mohawk guy there, though.
Yeah, you need one. Are you a candidate?
Yeah. Scott had a great comment about excitement and excitement in a SpaceX. I would say we have a ton of young folks in Lockheed. We don't have a Mohawk guy, but we have a ponytail guy who designed each unit. But more importantly, I think the excitement is not necessarily driven by a particular place, but the fact that we're doing something. The fact that we're building Orion has really driven the excitement in Lockheed. They have a huge amount of applications and a lot of people applying to get into the program because we're actually building it. And flying it is really, really important. One, to get the public's attention that exploration is actually in progress. I can have all the great PAO releases and all the great speeches, but the flight in December is going to generate a lot of interest and point people to what we're trying to do, so it's really, really cool. So that's it. So, any questions?
Understanding went with a little bit more flat shape, more oblique angle compared to Apollo. Is this so we can do a little bit more flying as we enter?
No, actually, it's very similar to Apollo. The L over D is pretty similar. We did a little bit, and we actually had to expand the orbit cover area a little bit because of the packing.
How many total kilograms of thrust or fuel in command module?
Oh, the exact loading, I don't know. They're 160-pound thrusters. I could probably get that for you. What the loading of the tank is.
Yeah, I noticed you had your first manned flight in 2021. In view of recent international developments, is there any plan to accelerate that? And if we're asked to accelerate that, when could Orion be flying with people?
Great question. So Bob was asking about when could we fly with people. The current plan is 2021, and also is the Russian thing. Could the Russian thing drive that? Two things I would say. The 2021 is absolutely driven by budget. In the last phase, and we recognize that the budget issue, there's a lot of things the country is trying to spend money on. So we recognize we got to fit. We were basically given a line. You need to fit under this line, and that line drove movement of test vehicles and qualification to the right, which is really why 2021 to date. So with more money, absolutely we could pull it to the left. So I think we can absolutely fly in that 19 time frame if we had the money. But just to be clear, again, the policy, the policy of this administration is that Orion is not going to go to space station. Right? Originally, we were designed to go to space station under Constellation, but the current president's policy is commercial crew guys will go to space station, and Orion is just going to be focused on beyond Earth orbit. But clearly, we have the systems we could do it. It's a policy question. Did I answer your question, Bob?
Yes.
Okay. Yes, sir.
Somebody pointed out to me that in an otherwise perfectly nominal mission, if you don't get that heavy launch escape system off the top of the booster, you're too heavy to get to orbit, and you launch your parachutes from deploy. So with your abort system, you've introduced a new failure mode that's predicting the loss of crew. So now SpaceX, which is escape system underneath, so it doesn't have that problem. Is that something that you guys looked at and rejected for another reason, or?
Yeah, great question. So it's an example of how size and other mission parameters can drive your design. So Orion is bigger. You've seen that already, right? It's bigger. The capsule is 20,000 pounds. It's for 4 people and those longer durations. So it's a bigger mission. So when you do that, if you tried to get, let's say, a pusher system, a blow-down pusher system to allow it would be very, very large, and you would carry that mass all the way to the moon because it's right. It's part of the service module. So for us, it made no sense.
The same way you do, I mean, after you've got yours, why can't you get rid of it?
Yeah, because when you're talking about putting it back in the service module, so then you mean adding another service module behind it. Now you got to push that thing. Yeah, but you're talking about not simple pieces of structure, but a whole prop system. That would be, well, we can talk about it. I think it's untenable, and that's what we looked at. Now, it is a key pyrotechnic event. I've got to separate, but it is a solid rocket motor that does the jettisons. Very highly reliable, simple solid rocket motor, 70,000 pounds. That's got a light, and we have redundant initiators, right, and redundant command pads. So it is a critical operation, but because of the reliability of the solid, we have confidence. But that's part of why EFT1 is so important. We're going to fly it and see if we learn anything about the aerodynamics. That would be the question. Are we getting any interaction with the structure as we release? And do we have any surprises in the environment? So, but it's a big system, and to pull Orion off safely, a 500,000-pound rocket, solid rocket motor is key. Now, service module does the aborts beyond the very beginning, right? Once we get the top off, the service module can do those aborts if we need to go closer to Ireland or bring us back to Newfoundland. So the service module is a key part. But as far as having enough energy in that early phase, making the service module capable of doing that would penalize us a lot. But it's one of the important things. Yes, sir?
Yes. What is the coldest temperature that the Orion will be able to launch? No, is there a risk of repeating the challenge of this actually?
So that would really be more a question on the rocket,
Yeah.
right, and the solids on the rocket. So I know since Challenger, especially the guys at Marshall, have done a terrific amount of work looking at the O-rings and the design of that system to characterize what the limits are. So I'm certain, I don't know the exact temperature limit, but I know they know it, and I don't believe it. It certainly is not any driver as far as our launch availability.
Yeah, we heard yesterday on SLS that they have several months of slack in the schedule towards EM1. What's the schedule like for Orion? How much slack do you have in your schedule towards EM1?
So a couple key things. So we put this EFT1 flight test in our plan without any more money. It was important for us to we thought it was important for us to fly before 17 years. So we stuck EFT1 in the plan, including the rocket cost. So that did affect my ability to start EM1 as early as I wanted to. Also, we added ESA to the program. They're doing a terrific job, but they had some challenges. So we're working through those challenges. So we're going to be challenged to make December 17. Now the exact date, we're working through our PDR now, looking at our risks, and so by the end of this fall, we'll be able to define that exact date. But the key thing is, we felt it was more important to build a flight unit and fly it, because we're going to learn so much about what the risks are that will significantly reduce the risk downstream of EM1 and EM2, because we've learned those issues and fixed them. So to us, it was worth the potential impact on EM1.
Since you said that Orion was potentially meant to take move to the International Space Station or the administrative shaking, so my question is two. One, what do you think of the Orion capsule that SpaceX revealed a month ago? And two, you said land on the water. What do you think of SpaceX saying that you can land on land and with an accuracy of the helicopter? So what do you think of those two?
Yeah, so I don't know a lot about the Dragon human spacecraft, and that's still work. I would say, first of all, I think Orbital and SpaceX have done a terrific job on their cargo vehicles. I worked on space station on ATV and HTV, the partner vehicles, and I recognize how hard it is to make a system that can do that. So they've done a terrific job. I think they're still very early in the integration of all the other stuff it takes to get people inside and the mass challenges you're going to have, but they're smart people. I have a feeling they'll figure it out. Again, landing on land, we found that we did a ton of studies, and we had a whole advanced development program that looked at airbags, retro rockets, everything else. In the end, to get a system that nominally landed on land, it was probably in the 50 to 1,600 pounds, if you think about the airbags, and you had to jettison the heat shield. So one, it added other risks for a system that has to work when you re-enter. And two was a lot of mass. And remember, you got to multiply that by 9 now for all the stuff it's got to push. It was a huge deal. So for us, it did make sense. For lighter capsules, smaller things where mass is not as big a deal, is not a big a driver. I'm not saying it's not important, but it's not nearly as big a deal. It might work. There are download issues, though, with landing on land. You think about where you're going to come in the U.S. You're probably going to come in the desert, right? East of Los Angeles. So there are download issues when it doesn't work. You got to come in short. So you probably have to design your system to land in the water anyway. Certainly you're going to land on the East Coast. If you have an abort, you're going to be in the water. So now your system has to do both, which adds complexity. So in our mind, it did make sense. But I wouldn't automatically say that will be the case. There's smart folks I know that are working hard on it.
Yes, we've heard a lot about SpaceX and other places. What can you say about having a national capability to do things?
National as opposed to?
SLV Orion as opposed to like whatever SpaceX is going to invent.
Yeah, so the question was, is it comparing what SpaceX is doing to SLS and Orion as a national capability? So I want to, first of all, clarify again, the Commercial Crew Program is a NASA-led program. There's no fuzz on that. Mike was very clear on this, where the money's coming from. NASA is looking at ways to reduce costs, so it's using the low Earth orbit, less risk region to see how it can apply different pressures to reduce costs, more fixed price deals, reducing some requirements, those kind of things. So it's all good. That's all good for everybody. But those low Earth orbit spacecraft cannot do what Orion and SLS can do as far as capability, as far as returning, as far as reliability, as far as the mass. They can't do it yet. And that's not the job they've been given. So to me, they're two totally different functions. They're not going to be, even though I know Elon likes to talk about he's going to go to Mars, which is cool. That's a cool thing for him. But the capsules today are built fundamentally to do different jobs.
And that has to be the last word. Thank you.